Okay, so a decay graph looks like this. This is decay. And a growth graph looks like this. This is a growth graph. These both have asymptotes right here at y equals 0. That is your asymptote at y equals 0. The equation for a growth, your b value has to be greater than 1 for you to get this type of graph, a growth graph. Your b value for decay is when b is between 0 and 1. That's how you'll get a decay. So, for example, f of x of 1/3 to the power of x looks like what? Show me in the air. What does it look like? Good, thank you. That's what it looks like. It is a decay graph that looks like this. Now, on your graphing paper, please show me what it would look like if I put a negative in the front. Let me know what it looks like. Graph it on your paper or your whiteboard. Okay, so we're graphing this one right here. What does a negative in the very front mean? Reflection over what? Yes, it's going to reflect over the x-axis. That means this x-axis is going to work like a mirror. It's going to look like this now. This is what your graph should look like. That's what your new graph should look like. Okay, guys, I'm going to change something very slightly. What will your graph look like if I put this negative inside of the parentheses? What if I put the negative right here? Now show me what your new graph will look like. This is the original on the screen. What does it look like now? Perfect. Yep, that's what it looks like. What does a negative on the inside mean? The y-axis is reflecting across the y-axis. So your new graph will look like this. It's reflecting across the y-axis. Okay? All right. So guys, I want you guys to try to graph this one. Tell me what this looks like. Try to graph it on your paper. Ready, go. All right, y'all had some good graphs on your boards. Let's talk about this. What does this tell me? It's decay. So I know that it normally will look like this. On the inside, I have a negative. What does this mean? What does it mean? It reflects over what? Over the y-axis. So now it looks like this. It reflects across the y-axis. Okay? What does that 3 do? It's not very important when I'm trying to figure out what it looks like, but what does that 3 do? It's a horizontal compress. By what? By 1/3. Okay, and then finally, this is important. It went down 1. So now I'm down here at -1, and that's what my graph looks like. I have an asymptote at -1. Okay? All right, so that's what your graph should look like. Now that we know what it looks like, we're going to talk about end behavior today. How we're going to talk about end behavior, let me just draw it right here for us really big. Okay, that's what our graph looks like. We're going to do end behavior. The notation that we use is as the limit as x approaches infinity for g of x. That's the graph we just drew. So what happens as your x values approach infinity? As my x values go to the right, what's happening to the graph? It's increasing. It's going off to infinity. That's how we describe the end behavior. Next one. The limit of g of x as your x values go to the left to -infinity. So let's follow my graph. I'll highlight it. As I move to the left, what is my y value approaching? -1. It's approaching the asymptote. So that would be -1. Those are your end behaviors. And that is how we're going to write it. We're going to use limit notation. Okay, now give me the graph and the limit notation for this next one. All right, so this is what you should have gotten. This is a decay graph. So I know it looks like this, but it was reflected across the y-axis. So now it looks like this. So this is my new graph. So the limit as x approaches infinity for g of x. As I move to the right, what's happening? It's increasing to infinity. And as your x values go to the left towards negative infinity, as our graph goes to the left, what's happening? It goes to 0, the asymptote, which is right here. Nice. Okay. Let's continue thinking about this. Please show me what this graph looks like. Actually, and I'm going to add something to it. I'm going to put a +3. Show me what that looks like. All right, guys. This is a growth. This is a growth. So it normally looks like this. However, it's reflecting across the y-axis. So now it looks like this. And then it went up 3. So now it's up here. 1, 2, 3, and it's up here. So your asymptote changed. We're right up here. Okay, so that means the limit as x approaches infinity for h of x, it's h of x this time. So as I move to the right, where am I headed towards? No, let me highlight it for you so you see my pen. I'm moving to the right. What number am I getting close to? 3. I'm getting close to that asymptote. Okay, and as I move to the left, so I'm going to start over here and I'm going to move to the left. Where am I going? Infinity. So my other limit, the limit for h of x as x approaches negative infinity is infinity. So these are your limits. Okay, I'm going to give you one more, guys. I'm going to change this. I'm going to make it like this. What does this look like? What does that look like? Very good job, guys. All right, so this is decay because this is 0.5. So it's decay. So it's facing this way. However, it's reflecting across the x-axis because the negative is outside the parentheses in the very front. So now it looks like this. And then your asymptote moves down too. So right here is where your new graph is. So I'll draw it nice and pretty over here. It went down to -2. So let's talk about the limits. Your limit as x approaches infinity for the graph k of x. Let's follow my pin. As I move to the right, what am I approaching? -2. And follow my pin again. As I move this way, where am I going? -infinity. So as I move to the left, as x approaches -infinity on the left, you go down to -infinity. So these are your limits for k of x. That's how we describe our end behavior. Okay, so this squared, what does that mean? Did any of you guys distribute the 2? No, you're not supposed to distribute that 2. This 2 means you have 2 of them. That means you're going to have 2 parentheses. This is x squared plus 4 times x squared plus 4. Now, if I FOIL this, if I multiply it, x squared times x squared is what, guys? X to the 4th. That's going to be the biggest degree you get, right? Because your next one is just 4x squared. This one is also 4x squared. And this is just 16. This is your leading degree. If this is even, that means you are going to have a U-shaped graph if you have an even power. Okay? Write this down somewhere because it's important. Even powered polynomials have the same end behavior. What does this mean? When I say they have the same end behavior, what does that mean? Yes, they're both going to go in the same direction. They're either both going to face up or they're both going to face down. What would need to happen in order for it to face down? Yes, this should be a negative. Then it would face down. But this one's facing up because it doesn't have a negative. So guys, I know my graph will look like this. Can you guys give me the limits? What would the limits be? Yep, they're both infinity. Okay? Let's do an odd one. If I had x cubed, actually no. Let's say I had x squared plus 1 times an x.
Oh, x cubed.
What is this?
Plus x.
This is x cubed plus x. This is a cubed. Guys, draw in the air what that would look like. There we go. It looks like this. It's going to look something like this. So when it's an odd power, they're going to have opposite end behaviors. Please write that down somewhere. You need to remember that. Odd powers have opposite end behaviors. And I'm talking any type of odd power. If this was x to the 5, x to the 7, they would have opposite end behavior. Does that make sense, guys? Okay. Show me what this looks like, and of course, give me the limits as x goes to infinity and as x goes to negative infinity. Okay, so I'm going to rearrange this in the format that we're used to seeing it, where the negative x comes first and the positive 1 comes second. Now, this is still not in the correct format. I'm going to factor out a negative. When I factor out a negative, what does this become? X, good. And what is this?
Negative.
Exactly. Because if I distribute it, I get negative x again. Distribute it, I get a positive 1 again. So we're not changing the value, we're just changing the format. Okay. And then, of course, we have a cube. So the transformations here, normally your cubic graph looks like this. However, it is now reflecting across which axis? The x-axis, because this negative is on the inside. It was negative up here. It was a negative x up here. It's reflecting across the y-axis. I'm sorry, did I just say x? I meant y-axis, because it's on the inside. If the negative is inside, like it is here, it's going to be the y-axis. So now it's going to look like this. That's what your graph looks like now. And then, guys, what else happened? It moved to the right 1. So now it's right here. This is what your graph should look like. So now that we have our end behavior, let me go ahead and graph it for us. This is what your graph should look like. We call this an inflection point. Your inflection point should be at 1. Okay. So let's talk about our limit. Follow my pen, follow my highlighter. When I move to the right, what's happening to my graph? I'm moving to the right. It's going to negative infinity. Thank you. And let's do the other one. I'll do it in yellow. Now I'm going to start and I'm going to move to the left. What's happening? Yep, positive infinity. So those are my end points. Those are my end points. Okay, let's try another one. So first with this one, you had to multiply it out. This is negative 2x times, we want 2 of these because it's a squared. 4x minus 2, 4x minus 2. Don't stress yourself out. What's 4x times 4x? 16x squared. The other ones, when you multiply it out, it's not going to be big as the squared. Okay? What's important is the leading term. So if you don't want to multiply it all out, that's fine. After that, this whole thing will be multiplied by this negative 2x. We're only worried about the biggest term. The biggest degree is the 2. So negative 2 times 16 is negative 32x cubed. This will be the biggest term, the highest degree. So guys, this is an odd degree. Any type of odd degree, what will it look like? Yes, it's going to go opposite ways. And so normally it would look like this, but I have a negative in the front. So now what? It would look like this. That's what your graph would look like. So now we can do our end behavior because we know what the graph looks like. Looks like that. And let's do the end behavior. Yep, they will be opposites. One will be positive, one will be negative. The limit as x goes to infinity of f of x is what? Negative infinity. The reason why, follow my highlighter, as I move to the right, it's going down. So that's negative infinity. And then the other one, the limit as x goes to negative infinity of f of x is positive because it goes up as you move to the left. Okay, we're going to move on from end behavior, and now we're going to go back to what we did last unit where we talked about if functions are even, odd, or neither. Before I start, even functions are functions where if you graph it, you can fold right down the middle from the y-axis, and it'll be perfect. So this is an example of an even function. It's an even graph. It's not a function because it doesn't pass the vertical line test. But that's a picture of something that's even. You can fold it. Does that make sense, guys? Okay. If you want something that looks odd, that means it's symmetric about the origin. So a good one would be the cubic. This cubic graph is odd because if you rotated this 180 degrees, it would be right on top of its current graph. It's rotating about the origin. Okay? All right, so let's figure out if these are even, odd, or neither of these, okay? So for this one, what did you guys get? It's even? Oh, neither, good, this is neither. We can also do the algebra test. If you plug this in, if you plug in a negative x, you get 2 plus 8x. That is not opposite of this, and it's not exactly the same. Remember the rules. If you plug in a negative x value, if you get the exact same function, it is even. However, if you plug in a negative x value and you get the exact opposite, it is odd. Okay? All right. Going back to this one, you can tell by either the graph or by plugging in a negative x if it's even or odd. What does this graph look like? It is even. How do we know? It's quadratic, so it's gonna be a U shape, and it only went down 0.5. Can you fold it? Yep, you can fold it across the y-axis, so it's even. Let's look at this one. You can either graph it and tell that it's gonna be neither. It's neither, or we can do it algebraically. If it's odd, just think about it. If this is odd, that means you'll get the exact same thing, just opposite, right? So if it is odd, I should get negative x cubed minus 3, correct? Okay. If it is odd, I should get negative x cubed minus 3, if it's odd. Let's see if that's what I actually get. So I'm going to plug in a negative x, and let's see if I get what I'm supposed to get. What is negative x cubed? Negative x cubed plus 3. Did I get this? So it's not odd. Did I get the exact same thing that I started with? Nope, so this is neither. Would you guys like to know a quick trick? I'll show you guys a quick trick. Before I start the quick trick, okay, the exponent here is a cubed. Everyone see that? The exponent here is a squared. What is the exponent on x? 1. What is the exponent on a single number, on a constant? 0. Everyone go ahead and add that to your papers. This 2, what is the coefficient? I'm sorry, what is the exponent on 2? What is the coefficient on this 3? Not coefficient, exponent. 0. Okay, this is the trick. This is even. We're going to count 0 as even. But this one's odd, so that's neither. This is even, but this exponent is even too, so it's even. This exponent is odd, but this exponent is even, so it's neither. Let's try to do the other examples and do the same trick. Okay, so we have 3x to the 4th power minus 5x squared plus 1. Guys, what exponent do I put on a constant? 0. Are the exponents all even? So this is even. Next one, I have 2x minus 5x cubed. Guys, what exponent do we put on x's? A 1. Are they both odd? So this is odd. Next one, we have x to the 7th plus, plus x to the 5th power minus 3x minus 1. What exponent do we put on x? And what do we put on a constant? 0. This is odd, this is odd, this is odd, but what do we count zeros as? So what is it? It's neither. Yes. What's supposed to be a 5? This one? Oh, sorry. This is a 5, sorry, but it's still odd, so it's odd. Thank you. All right, next one. We have 1 minus x. What is the exponent here on x? 1, and the exponent on a constant? This is even. This one's odd, so it's neither. Okay, I'm going to pause here. Let's go over this algebraically, because I want y'all to know how to do all the ways possible. So let's do this algebraically. We can move this so that it's in the proper order. Just rearrange it. What do we do next, guys? Oh, you're doing it algebraically. I meant, how do I do the transformation? It's already flipped. I'm going to take out a negative. So now it looks like this. So if I were to graph this, it reflects across the y-axis. and it goes right 1. So if I were to graph it, it's normally a V shape. If it reflects across the y-axis, it looks the same, but now it's here. So that is neither.